makes this piece one of my favorites. Dun, 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 dun. Heaven to my ears, but unfortunately we'll have to end it right there before I get ahead of myself. That, my friends, was a little snippet of Waltz Number 2 by Dmitri Shostakovich, a piece from his Suite for Variety Orchestra written 100 years ago in 1935. All right, now, moving on to more contemporary developments. As climate shifts and environments become more hostile, many living organisms are mutating for survival, evolving new mechanisms to protect themselves from predators. 17 researchers from the Department of Evolutionary Biology at the University of Toronto have identified genetic mutations essential to ecological resilience as detailed in the paper Adaptation Mechanisms in Response to Climatic Shift. Even the simplest botanical and zoological organisms exhibit remarkable evolutionary adaptations. Some have developed biodefense mechanisms so finely tuned they can detect micro-level threats within their environment, deploying reactive compounds to mitigate potential harm. Concerns in evolutionary biology are growing over this unpredictable mutation, which seems to be mutating and affecting organisms at random.
Mutating?
One such example includes the discovery of Thermococcus marinus, a deep-sea microorganism capable of adapting its cell structure to extreme conditions. The cellular mutations allow it to withstand intense pressure and temperature variations. While these adaptations are primarily protective, some organisms have evolved mechanisms, a process scientists are now calling aggressive evolution. Some species, like stingrays, have evolved to release powerful chemicals so potent that even brief exposure can overwhelm the senses, causing intense physical reaction and incapacitating those who come into contact with them. Terrestrial flora have also shown signs of aggressive evolution. Recent studies indicate that botanical species have begun evolving defensive traits in response to environmental pressures. Scientists have observed that certain plant species now produce bioactive compounds so potent they can disorient or repel potential threats. This remarkable chemical evolution marks a turning point in the plant kingdom's adaptation, transforming passive flora into active defenders within their ecosystems. First recorded in 1977, the plant species Luminaria noctis was noted for releasing faint bioluminescent compounds at minimal levels. Recent findings reveal a staggering 350% increase in these emissions, a change accelerating faster than any recorded over the past millennium. Scientists question whether these intensified emissions are part of a broader survival strategy, with certain plants exhibiting traits once thought exclusive to advanced organisms. This raises intriguing questions about the evolutionary pathways these plants may be taking. These traits may vary not only based on an organism's morphological characteristics, such as size, shape, and genetic composition, but also its physiological, behavioral, and symbiotic traits. More importantly, these adaptations are shaped by the organism's environment and competition.
I hate crying.
As organisms adapt to increasingly hostile environments, their mutations ensure survival at any cost.
As the fundamental structure of the food chain shifts beneath our feet, it's uncertain which species will rise, which will fall, and which will maintain their position. Who knows who will emerge as our equal in this evolving ecological revolution?
adapt, or die.
Hey Siri, call the police.
Calling Reese.
No, 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 that's not what I want.
And with that, we end today's science segment. Coming up tomorrow at 0900 PST, an exclusive interview with Dr. Sage Hollis about recent dietary trends, the science behind plant-based eating, and the underrated health benefits of the onion. Stay tuned.